Hi everyone! I have this simple Hanami API application allowing me to list some draft articles and published ones under separate endpoints. However, none of those endpoints is authorized, which means that anybody can access all my resources at any point in time. I would like to have all my requests authorized by default instead, according to the secure by default principle. And for that, I will want to go with the JSON Web Token authorization. In this episode of Hanami Mastery, I will show you how to implement the Jwt Authorization mechanism and a simple access check to verify the rights to access the given resource. In the Web API, there are usually at least two levels of authorization. First is the application level, when we register the client application in our system and give it particular access, such as user session management or registration. Then the other level of accessibility is when a user gets logged in and tries to access available resources. A nice example is a GitHub OAuth application setup, when you can register an application that can connect with GitHub API, and only when you use it to log in a user, you get access to more resources like own private repositories, for example. The reason for that is simple. Skipping authorization checks for endpoints like registering users is a serious security issue in any system and can lead to various vulnerabilities for hacker attacks. Today I want to show you just the Jwt authorization, and for the sake of this example I assume that you have the authentication mechanism implemented already. If that's not the case, I will cover authentication in one of my soon-to-be released episodes. You can subscribe to my channel to be sure you won't miss it, and support me to speed things up. To implement authorization for my Hanami application, I will use the Jwt Gem, which is a tiny wrapper on top of the standard Jwt implementation for Ruby, to simplify the integration with web apps and reduce the overhead required to add it in any, and I mean any rack-based application. In the README of this gem, you can even get a plain Ruby script with only a few lines of code that just works. It's done by keeping the gem rack compatible, which allows for such flexibility of implementing it in any application you want. I wrote it because I wanted to play more with Jwt Gem, which I showcased in the previous episode, but also because there was no robust Jwt authorization mechanism available for rack applications yet. Jwt Gem uses dry effects under the hood to manage non-local state, together with dry configurable for an easy configuration. In this episode, I will show a Jwt authorization example by using Hanami 2.0 sample application. But if you are using Rails, Sinatra, Roda, or even a plain Ruby, the integration is almost identical. This gem is created by me and was originally named Jwt, or rather UTI, as I quickly learned. And the name was a result of me trying to have a fun of the English language, but it appears that the language had the fun of myself instead. I just wanted to write what I hear when I read Jwt words, but I forgot how the I letter is usually read in English. Then it appears that UTI is an actual acronym and quite a popular one, standing for urinary tract infection. I would never guess that on my own, and if you combine that with the fact that the J letter doesn't necessarily need to refer to a letter, you may come up with the idea that Gem's name refers to J's double UTI. I can think of people having nicknames or even names from the J letter, so I renamed the gem while keeping this note for future myself as a reference to be more careful when naming things. Apologize to all J's in the world, and big thanks to Tim Riley for pointing out this English phenomenon. This is the pure essence of benefits from being a blogger and open source contributor. Just by publishing any of my work, I get so much great feedback from all of you that I can improve at the pace I would never be able to if I would keep my thoughts for myself. If you consider starting blogging or recording videos, I highly recommend it. So thanks, and as always, if you will ever find anything where I could improve, let me know. I love tweaking up anything I tackle. Anyway, back to the topic. First, I need to add the Jwt Gem to my gem file. Then run bundle to install new dependencies, and we are ready to configure our authorization stuff. To authorize the endpoint, I need a token. As Jwt uses RSA algorithm by default, I will generate the private and public key pair and the token itself just for testing purposes. For that, I will use script copied from the README, however, with a little adjustment to the payload to add a sample scope that will be useful later. To generate the token, I need a private key, but to verify it later, in the authorization, I only care about the public key. This may be useful when you have a separate service to generate your tokens and authenticate users, while the rest of your systems only need to check if the tokens incoming to the server are valid or not. I will copy my public key to the environment variable and save it in the env file. The generated access token I will save in the Postman application in my request example for later use. I do have the public key set in the environment variable now. However, it is not yet accessible in my Hanami application settings. In Hanami, application configuration settings are read from environment variables automatically, but each setting needs to be explicitly defined with the expected type set. This prevents unwanted environment variables to be accidentally loaded in the application. It increases security and minimizes the issues related to undefined values being set on staging or production environments. I love this feature as there is no way to even run the application with invalid configuration, reducing the time to debug issues related to it. Here in the setting RB file, I'm going to add a new setting named the same way as my variable name to be read automatically. It's Jwt public key. I will set this as a required value of a type of string. From now on, if there is a missing public key in the environment variable, my application will crash on boot, reporting the invalid nil value in the environment variable. Now let me launch the console and check if the setting value is properly loaded and is accessible in the container. It is. So now I can configure the Jwt Gem in my project. First, let me add a new boot table component to be registered on application start. In Rails environment, you would look for an initializer. I will add here a new file named Jwt, and inside I just register a new boot table component named the same way. Inside, I will require Jwt Gem on init, and on the startup, I will configure the gem to read my public key. I don't need to set the algorithm here because Jwt uses RSA signature by default, and this is the one I use in this showcase. However, I do like to have explicitly set such things in the app for easier reference in the future when reading the code during reviews and applying changes. Then let me configure the secret key to be read from just set container settings. Having the gem installed and configured, I only need to use it. For that, I open the config.ru file and add my Jwt Authorization middleware to the application stack. Now let me start the server. And when I will open the Postman now, I will get an unauthorized error response for my drafts. This is neat. If I will set the authorization header in my request, setting the token to the just generated string, my app will return the actual response. That is awesome. But what if I would like to check additional access criteria in my article drafts action to allow the client to list my draft articles only if the token contains a certain scope in the payload, or the current user ID is present in the token payload. For that, I need to have an access to the payload stored in the token. With Jwt, it's extremely easy. In your action, just include Jwt Auth module, and from now on, I have access to the Auth object, which is the coded payload extracted from the requested token. If I will render it here, you will see exactly the payload I used to generate the token earlier. Having that, I can have a very fine-grained control over the access verification for any of my actions. I can now verify if the user has access to the requested resource by adding a check if the scope of my decoded token includes the public articles one. Then I will render the valid JSON response only for this case, otherwise returning an error to the browser. Now when I visit the postman, I get the forbidden error response due to invalid scope being set. By changing it to public.read and refreshing the request, I will see the correct data now. Having that, I can do any access check I want. However, what I did here is adding an authorization logic to my action, which is not great. What I really like to do instead is to write separate atomic authorizers for every action in Hanami or Rails and extract common code to shareable places when I will start seeing repetitions and patterns. For the sake of this example, let's just create a guest authorizers in the lib authorizers folder of my main slice. Then we need to define it, and it will contain only one method, call, that accepts an auth argument followed by anything. This is because authorizers usually need to check the actual object to verify access, which I call subject. In this case, however, I only use the auth scopes, so can keep the other arguments undefined. Then inside, I paste the access check logic for my guest user. I also check here if the passed auth object is successful to keep authorizers self-contained. If the auth contains scopes, we check if it contains a particular one for public read and return false otherwise. This approach is super easy to extend later, and as each authorizer is self-contained and kept very small, changing the logic of permissions is usually trivial even far in the future. A quick note here about the call method. What I usually do here is, instead of returning the true-false value, return the success or failure monad with a more detailed value passed inside. I cover monads in episode 7, so feel free to check it out. This allows me to chain returned values together and keeps my code way less bug prone. However, it's a topic for a different video. Then, in the action, I only need to call my authorizer and inject it as a dependency using the deps module for the main slice. The behavior of my application stays the same. In the browser, I get the successful response for the correct scopes, but if I will change it, I get forbidden response instead. Implementing authorization in Rack application can be trivial, and as basically any Ruby web application is based on Rack, if there are Rack-compatible gems to achieve a particular task, integrating them can be as easy as making a toast. That's all for today. I hope you enjoyed this episode and that my ridiculous naming setback will help you prevent such issues in your career. I want to especially thank my recent sponsors, Andrzej Krzywda, Sebastian Hribar and Jwt for supporting this project. I appreciate it a lot. By helping me with a few dollars per month creating this content, you are helping the open source developers and maintainers to create amazing software for you. And remember, if you want to support my work even without money involved, the best you can do is to like, share and comment on my episodes and discussion threads. Help me add value to the open source community. Also, as usual, check out 2 of my previous videos here. Have a nice rest of your day, you are awesome. And see you in the next Hanami Mastery episode.